All right, here we're going to look at some transformations. Number 16 says, how can the graph of our function f of x equal 3 times the square root of negative x plus 2 be obtained from the graph of f of x equals the square root of x? So our function square root of x has been transformed by multiplying by a factor of 3. And since this is on the outside of the square root, that means it's going to be a vertical stretch. This negative here is on the inside of the square root, which means it's going to be a horizontal reflection across the y-axis. And then we're going to be shifting it up 2. The plus 2 is on the outside of the square root. That means it's going to be a vertical shift up 2 units. So the way we just describe this would be a vertical stretch by a factor of 3. And then we're going to have a reflection, which is horizontal, so that's across the y-axis. And then it's going to be a shift up by 2 units. Okay. Now here we're asked to graph the function, the translation or transformation. So here there's going to be a vertical stretch. We have a quadratic function. This -1 inside the square means it's going to be shifted to the right 1 unit. Outside, the -5 means it's going to be shifted down. So the vertex is going to be 1, -5. So here's 1, -5 right there. It opens up because the leading coefficient here is positive, and it's going to be stretched. So normally we would have this point, these 2 points be on the graph, but it's stretched by a factor of 2. So instead of being here, it's going to be here and here. So it's going to be taller and skinnier. Here we have a square root function. Normally the square root function passes through the origin, 1, 1, and then 4, 2, with a shape like that. But because we have a negative on the inside multiplied, it's going to be reflected across the y-axis. Here's our y-axis. So it's going to be reflected. This point is going to be over here. And then this point is going to be over here. So it's going to look like that. So here's the original and here's the reflection. Now we have the absolute value function. This negative on the outside means it's going to reflect across the x-axis. So on the outside, it's a vertical reflection. And so here we have a horizontal reflection. Now it's going to go across the x-axis right there. And the absolute function is shaped like a V. And it's then going to be, after it's reflected, it's going to be shifted up 5. So I'm missing a line there. I don't know why that didn't show up. So we have 1, 2, 3, 4, 5, and then it's a V-shaped. So the reflection happens first. That's why it's reflected across here, and then it's shifted up 5 units. Here we have the square root function. It's on the outside. The negative is on the outside. That means the reflection is going to be across the x-axis. And so when you reflect it, it's going to be down here like this. So it starts here, gets reflected across the x-axis, and then it's going to be shifted to the left by 2 units. So that would be 1, 2 here, like this, after the shift. Here we're asked if the function is even, odd, or neither. The way we do that symbolically is we replace x with negative x. So f of minus x is going to be negative x squared plus 4. When you square a negative, you're going to get a positive, right? So it's going to be x squared plus 4. This function, f of minus x, is the same as f of x. So that means the function is even. Do the same thing here. We get f of minus x. Plug it in, we get minus x cubed minus 5 times minus x. So this is going to be, when you cube a negative, you still have a negative. So it's going to be negative x cubed. The double negative here becomes plus 5x. And what you'll notice is that this is the opposite of our original function. This is just minus x cubed minus 5x, so minus f of x. So when you plug in a negative x into your function and you get the opposite sign of your original function, then you know that you have an odd function. And finally, here I'm plugging in f of minus x. I get 3 times minus x squared minus x plus 2, which is 3x squared minus x plus 2. And this is neither the opposite or the same. It's something entirely different. So it's neither even or odd. Even functions are symmetric with respect to the y-axis. So this function, x squared plus 4, is something like, it's a parabola. And if I reflect it across the y-axis, I'm going to get the identical function. So that's true for even functions. And then here, minus x cubed minus 5x. Let me go ahead and share my screen and we'll take a look at Desmos to do this. So when I type in y equals, let's see here, y equals x cubed minus 5x. Here you can see it's a cubic function, and if I type in the line y equals x, imagine rotating 180 degrees. This point is going to come over here. This point is going to swing around over here. Just imagine rotating 180 degrees. This point is going to stay put. You're going to get the identical graph when you rotate that function around the origin 180 degrees. Okay, you're going to get this point coming around here, this point coming around here, and then this point coming over here. So rotating 180 degrees, you're going to get the same graph. That shows that it's odd. Okay. So you have something like this. And again, rotating at 180 degrees gives you the same thing.